So this says a sample found at a dig site was determined to have 68.7% of the C14 still remaining. Use that model to determine the age of the sample. Okay, so if it has, so the amount of C14 left will be equal to 0.687 times the original amount, right? And so what we want to do is 0.687 Q naught is equal to Q naught E to the negative 0.1230121 T. Okay, and then I can divide both sides by Q naught. So the Q naughts are going to go away. So I'll have 0.687 is equal to E to the negative 0.000121 T. Now I can take the natural log of both sides. And then I can divide by negative 0.000121. So T and then it says round to the nearest year. So let's stick that in our calculator. Natural log 687 divided by negative 0.000121. I got 3,102.6, so 3,103 years. We round up. Okay, so the next one. So given the following data, use your graphing calculator to find an exponential regression model that fits the data. Okay, so for that, I'm going to go to Stat, Edit, and then type all of this in my lists. Okay, so in list 1, I'm going to put 1, 2, 3, 4, 5. And in list 2, 2.4, 3.5, 5.5, 8.1, 12.0, and 18.4. And then I'm going to go Stat, Calculate, and I want to do an exponential regression. And so it looks like it has round to 3 decimal places. So my calculator gives me y is equal to 2.382 times 1.503 to the x. Okay, so that's the exponential regression model. Okay, last one. A lake is stocked with bass by the U.S. Park Service. Population of bass in the lake is given by that logistic model. Evaluate P of 0 and interpret its meaning in the context of the problem. So P of 0 equals 3,000 over 1 plus 2e to the, well, if I plug in 0 for t, that's 0. So that's 3,000 divided by 1 plus 2, which is just going to be 1,000. And so that means that is the population of bass when t equals 0. So that's the original amount of bass that were stocked in the lake. So 1,000 is the initial population of bass. Well, it's the size of that's the size of the initial population of bass. Then use the function to predict the bass population 4 years after the lake was stocked. So that's just P of 4. So I'm just going to plug in 4 into that. So I have 3,000 over 1 plus 2e to the negative 0.37 times 4. So when you plug this into your calculator, you need to make sure that you have parentheses around the whole bottom and parentheses around this stuff that's up raised to the e. So you're going to have a lot of parentheses going on there. Okay, so we're going to do 3,000 divided by, open parentheses, 1 plus 2 e to the negative 0.37 times 4. Close those, close the whole bottom, and then I got 2,061.4. 0.46. Well, it doesn't really make sense to have 0.5 of fish, but anyway. Yeah. Determine the number of years for the bass population to reach 2,800. Round to the nearest year. Okay. So I want to set up an equation where I have 2,800 is equal to 3,000 1 plus 2e to the negative 0.37t. Okay, so first I'm going to multiply the whole thing by the denominator on this side. So I'm just going to multiply this over to the other side. So that's going to give me 2,800 times 1 plus 2e to the negative 0.37t equals 3,000. Then I can distribute that into those two. 2 times 2,800. Then I can subtract the 2,800 and divide by 5,600. Okay, so 3,000 minus 2,800 is 200, and then I divide that by 5,600. So I get 1/28. Okay, and then I can take the natural log of both sides. So I get negative 0.37t is equal to the natural log of 1/28. And then I can divide by negative 0.37. Round to the nearest year. Natural log of 1/28 divided by negative 0.37. I got 9 years.